Okay, so good day. So we are now on quarter 2, module 2 of Mathematics 10. Relationships among chords are central angles and inscribed angles of circles with the code M10 GE-LIC-1. So in this episode of our video, we will discuss only on the properties of circle. Our objective is to identify inscribed terms related to circles. So let's review now on properties of circle. Circle is a closed figure, consists of many points or infinite points equidistant from a common point called a center. Okay. So a circle can be named through its center. So if the center of that given circle is point A, then we name this circle as circle A. So point B, C, point D, point E, point F, point G, point H, and point I are points on the circle. Uh, A segment or distance from the center to any point on the circle is called a radius. So if we connect point A to point B, that is a radius. So we use the notation small letter r to symbolize the radius. So therefore, segment AB, segment AC, segment AD, segment AE, segment EF, segment AJ, segment EH, and segment EI are radii of circle A. So radii is a plural form of radius. So radii of the same circle are always congruent or equal. So it means that segment AB is congruent to segment AC. And congruent also to segment AD, congruent to segment AE, congruent to segment EF, congruent to segment AG, congruent to segment EH, and congruent to segment AI. So if the measure of line segment AB is 10 units, and so therefore the measure of line segment AC this one, is also equals to 10 units, and so on. So a line segment connecting any two points on the circle is called a chord. So therefore, segments ADB, if we connect that segments DB, so D is on the circle and B is also on the circle, connecting any two points on the circle, you form a chord. So that DB is a chord, CF, and ES is also a chord. So they are chords of circle A. So the question is line segment FB a chord? So we are still connecting any two points on the circle. But this time, it passes through the center point A. So the answer is yes, it's a chord connecting point F and point B, which lie on the circle. So it is a special chord which passes through the center, and we call this as diameter. Okay? So diameter. So it is a chord which passes through the center of the circle. So the measure of diameter is equals to twice of the radius or 2r. Okay. Or we can use the notation or equation d is equals to 2r or r equals to 1 half of diameter. So therefore, if the measure of the radius AB is 10 units and Therefore, the measure of diameter FB is equals to 20 units. So the diameter also divides the circle into two equal parts. Okay. So the diameter FB divides the circle into two equal parts. So it creates a two semicircle. So half of a circle is called a semicircle. So let's proceed now to arcs on the circle. So arc is a part of the given circle. So we have three classification of arcs. We have the minor arcs, which measures less than 180 degrees. Semicircle measures exactly 180 degrees. And major arc measures greater than 180 degrees. Example, so we have that arc DB, arc FI. Okay. So this DB and FI are minor arcs because the measures less than 180 degrees. If you notice on the figure, so arc F going to I not reach on point B because if it reaches to point B, it measures 180 degrees. So we can use only 2 points to represent minor arcs. So don't forget that the diameter divides the circle into equal parts. So therefore, if a circle has a measure of 360 degrees in one revolution, then half of this is 180 degrees. So therefore, the arc FDB, this one, FDB and arc BHF are semicircle. So it measures exactly 180 degrees. We use 3 points to represent a semicircle. So we have now arc BGD. So from point B passes to point G to point D. Okay, that's arc BGD, or we can name this also as BID. So you can use any points between the two points of the endpoints of the arcs. So we can name this also as DEB. And arc, we have GDI, arc from point G, and from point G to I. So they are major arc, measures greater than 180 degrees. So we use also 3 points to represent a semicircle. So let's talk now about angles on a circle. So we have that angle DPB, and angle LOB. So we can name this angle DPB as angle BPD also, as long as the vertex is the center of the given angle. Okay, and also angle LOB can be named as angle BOL. By the way, in an angle, this point of intersection of two legs of an angle is called the vertex. Okay, so what do you think the difference of the two angles? So if you notice, the vertex of the first angle or angle DPB is at the center of the circle, while angle LOB, the vertex is on the circle. Okay, so what are the difference of this? So if an angle on a circle whose vertex is the center of the given circle, we call this as central angle. While if an angle on a circle whose vertex is on the given circle, we call this as inscribed angle. Okay. So therefore, that angle DPB or angle BPD is a central angle, and its intercepted arc is arc DB. So this arc DB is called intercepted arc of angle DPB, while angle LOB or angle BOL is an inscribed angle where its intercepted arc is arc LB. So an intercepted arc is an arc of a circle along the opening of the given angle. Okay? So let's repeat that central angle. The vertex is on the circle or on the center of the circle, while in inscribed angle, the vertex is on the circle. Okay. So how to measure central angle and inscribed angle? So the measure of central angle is equal to its intercepted arc. Equal. Okay, take note that the measure of central angle is equal to its intercepted arc. So if the measure of arc dB is 60 degrees, and so therefore the measure of that angle dPB is also 60 degrees. So they are equal. Or we can say that the measure of angle dPB is equal to 60 degrees, and therefore the measure of arc dB is equal to 60 degrees. That is vice versa or converse, no? Okay. So while in inscribed angle, the measure of inscribed angle is 1/2. Okay. The measure of inscribed angle is 1/2 of its intercepted arc. You take note that class. So 1/2 of its intercepted arc. So if the measure of that arc LB is 100 degrees, and so therefore the measure of this angle LOB is equals to 50 degrees because it is 1/2. Okay? Or we can say that the measure of angle LOB equals to 50, then the measure of arc LB is equals to 100 degrees. So let's have now an exercises. So we have given circle A because the center is point A. So if we're going to connect line segment EI, which passes through the center, so we form a diameter. Okay, so that is now a diameter EI. Okay, and then let's connect another segment. So let us say this is segment AB, connecting the center to point B on the circle. So that is what we call the radius. So the radius is AB. Okay. So if the measure now of the arc BI, if the measure of arc BI is, let us say, 45 degrees, okay, that is 45 degrees. So what is the measure of angle BAI? What is now the measure of angle, the measure of angle BAI? So in the definition of central angle, since it is a central angle where the vertex is at the center, so the measure of central angle is equal to its intersected arc. So it means that the measure of this angle is also equal to 45 degrees. Okay, it's also 45 degrees. Okay? So the measure of angle BEI is 45 degrees. Okay, and then what is now the measure of if we form another angle connecting E point E to B, which is a chord, that is chord EB, and we form an angle BAI. So in what is now the measure? Okay, what is now the measure of angle BEI? Okay, so this angle. So angle BEI is an inscribed angle, and the measure of inscribed angle is one half of its intercepted arc. So the intercepted arc is also arc BI. So it means that the measure of that angle BEI is one half of 45, one half of 45 degrees. Okay. And what is one half of 45 degrees? So the measure now of angle BI is 22.5 degrees. Okay. And what is the measure now of the measure of arc EGI? That arc EGI. Let's find this arc from E going to G to I. So of course it is 180 degrees because the diameter divides the circle into two congruent parts. Okay. So now, if this BI is 45 and this EGI is 180 degrees, okay, this arc. So this arc is 180 degrees. And what is now the measure of this arc EB? Arc EB. Okay. So what is now the measure of arc EB? What's to what now? Okay, so since the one revolution of a circle is 360 degrees, and it's also already 180, this is 45. So what is the remaining measure of this arc? So that is 180 minus 45 or 135 degrees. So the measure of this is 135 degrees. Okay, so that's how to find the measure of the parts of the circle. So if line segment DA is a radius, and we have another line segment there. Okay, so let us say this is point P, point P. Okay, and the measure of angle. So the measure of angle DAC, DAC is equal to 30 degrees. Then what is the measure of arc DC. Okay, that is measure, no? The measure of arc DC is equal now to 1. So of course, it is also 30 degrees. Okay, so this is 30 degrees. If this is 30 degrees, so this intercepted arc is also 30 degrees. Okay, so let's have another segment. Okay. So if A is also a radius, okay, and we have also this segment. Okay. Fine. Okay. So patuloy natin yung yeah. So if the measure of this angle or arc FD, if the measure of arc FD is 90 degrees, then what is the measure of this angle? Angle FAD. So it is also 90 degrees. And about this angle, inscribed angle. So if this is 90, so of course this is 1/2 of 90. So this is 45 degrees. And if arc FD is 90 and DC is or DP is already 30 degrees, so what is now the measure of this arc PB? Arc PB. What is the measure now of arc PB? Okay, so we have diameter FB. So it means that it is 180. So we have already 90. That's 30. So that is 120. So therefore, the measure of that arc FB is equal to 60 degrees. Okay, that is 60 degrees. Okay, so that's how to find the measure of angles, arcs, uh, and other measures. Okay, so what is now the measure of arc BI if the measure of arc FI, if this is, if the measure of this is 150 degrees or 130 degrees, what is now the measure of this arc BI? So of course it is 50 degrees to make it 180. Okay, so that's how to solve for the measures of angles, inscribed angles, central angles in arc of on the circle.